All right, in example 4, we're asked to write the equation of a line parallel to y equals 2x plus 1 that passes through the point negative 1, 6. And you want to recall from geometry that parallel lines have the same slope. So if I'm using the point slope form of a line, y minus y1 is equal to m times the quantity x minus x1. I need to know two things. I need to know the slope of the line, and I need to know a point on the line x1, y1. Well, since the slope of the given line is the coefficient on the x in slope-intercept form, the slope of the given line is 2. And since parallel lines have the same slope, the slope of the parallel line will also be 2. So I can substitute a 2 into this point slope form of the line for the m. Okay, then we know that the equation asks us for an x1, y1. That's a point on the line, and that was given to us as negative 1, 6. That's our x1, y1. So we're going to substitute negative 1, and we're going to substitute 6 into the point slope form of the line. So we have y minus 6 is equal to 2 times the quantity x minus a negative 1. So when we simplify, y minus 6 is equal to 2 times the quantity x plus 1. Okay, if we wanted to put that into slope-intercept form, we could distribute the 2 over the parentheses and then add 6, and slope-intercept form would be y equal to 2x, and then 2 plus 6 is 8. So y is equal to 2x plus 8. If we wanted to put this into standard form, we could subtract the y from both sides, subtract the 8 from both sides, and we'd have 2x minus y is equal to negative 8. In B, we're asked to write the equation of the line that is perpendicular to 2x plus 1 and passes through the point negative 1, 6. Parallel lines, we found, have the same slope. Perpendicular lines, if you recall from your geometry class, those have opposite reciprocal slopes. So if the slope of our given line is 2, right, that's the m, the coefficient on the x in slope-intercept form, the opposite reciprocal of 2 is negative 1/2. Remember, reciprocal means to flip our fraction upside down. So the reciprocal of 2 is 1 over 2. And opposite means the opposite sign. And the opposite of a positive is a negative. So we're going to use the given point, negative 1, 6, as our x1, y1. We're going to use the new slope of negative 1/2 in point slope form to write the equation of this line. So y minus y1, which is 6, is equal to m, negative 1/2, times the quantity x minus, and our x1 is negative 1, and a negative is a positive. Okay, now we're going to distribute to put this into slope-intercept form. So we have y minus 6 is equal to negative 1/2 x, and then a negative times a positive is a negative 1/2. Now I'm going to multiply through by 2 to get rid of those fractions. And distributing that 2, I have a 2y. 2 times negative 6 is negative 12, is equal to 2 times negative 1/2 is a negative 1. Then x, 2 times negative 1/2, again, is a negative 1. Okay, now we want to get into standard form. So we're going to add x to both sides and add the 12 to both sides. So we'll have x plus 2y is equal to, and then adding 12 to both sides, we've got a 12 minus 1, which is 11. Okay, so let's take a look at the graph of these two lines. And here is Desmos. Okay, so we're going to first look at y equals 2x plus 1. Right, there's my y-intercept of 1, and my slope goes up 2 over 1, up 2 over 1, up 2 over 1. Okay, next let's look at our standard form, x plus 2y is equal to 11. And here we can see these lines are in fact perpendicular. Remember from geometry, perpendicular lines intersect to form right angles. Okay, now let's look at the parallel lines. So the line parallel to y equals 2x plus 1 was in standard form 2x minus y equals -8. And when we slide over again, take a look at those lines in Desmos, we see that they are in fact parallel. Remember from geometry, parallel lines do not intersect. They have the same slope, but different y-intercepts, right? And we can see our two different y-intercepts there, but the slopes are still 2, up 2 over 1, up 2 over 1. So on your whiteboard or on some scratch paper, you're going to pause the video and then write the equations of the lines that pass through the point -2, 3, but are parallel and perpendicular to y equals 4x minus 6. Okay, once you have written the equations of the lines parallel and perpendicular, to 4x minus 6, but that pass through -2, 3, go ahead and graph those lines on Desmos and show yourself to verify that what you did is correct. Okay, so when we look for the equation of the parallel line, we use the same slope. So the slope is 4. We use the -2, 3 as our x1, y1, and point slope form then is y minus 3 equals 4 times the quantity x minus -2. In slope-intercept form, we're going to distribute that 4 over the parentheses, add the 3, and we get 4x plus 11. In standard form, we'll subtract the y from both sides, subtract the 11 from both sides, and we have 4x minus y is equal to 11. When we graph that in Desmos, those two lines together, we can see that they are in fact parallel lines. They have different y-intercepts, but the same slope. Now let's take a look at the perpendicular lines. So perpendicular lines have opposite reciprocal slopes. The opposite reciprocal of 4 is -1/4. So again, we're going to use point slope form of a line, given this point -2, 3 as our x1, y1, and -1/4 as the slope. So point slope form is y minus 3 is equal to -1/4 times the quantity x minus -2. Right? A negative and a negative is a positive, but when we distribute this -1/4 over the parentheses, we're going to have a -1/2 on this side. And then we add 3 to both sides, and slope-intercept form is -1/4 x plus 5 over 2. Then to go from slope-intercept form to standard form, we would multiply all three of these terms by -4, and then rearrange our terms so that the x and y are on one side and the constant is on the other. So standard form is x plus 4y is equal to 10. To show in Desmos that these are in fact perpendicular lines, right, we're going to look at those two graphed together, and we see that they do in fact intersect to form right angles, right, a 90-degree angle. And that shows us that these are perpendicular lines.